Hello, my dear viewer. I hope you're having a wonderful day. Today I'm going to be talking about FabricPath and how you can run it on GNS3. But first and foremost, if you have any problems related to running NXOS V on GNS3, you are more than welcome to Google it. It's not a video about that. So David Bommel has already created a lot of wonderful videos about virtualization and virtualized operating systems and simulators. So you can just seek out David Bommel. And first I'm going to add my Nexus switches here, but because it's going to take me a few minutes to boot up, I'm going to talk about the history of FabricPath a little bit while they are booting up. And because it's going to use a lot of resources, I'm going to add them one by one. So first I added my spine switches, and then next I'm going to be adding my leaf switches. So if you're searching for the configuration part, please skip the video to the configuration section and let me talk about my baby a little bit. So FabricPath. What is FabricPath? I'm going to start it with some words of wisdom by myself. I say redundancy is a must, but at what cost? Yeah, redundancy is really important. What redundancy is simply is just saying that two is one, one is none. So when you have two things of something, in case of failure, you have only one. And if you have one, you have just none. Yeah, two is one, one is none. So I personally believe that you have to have a redundant thing of everything, at least about the major important things in your life, such as your keys, your glasses, your phones, your laptops, your pets, your best friends, your partners. Oh, not those ones? Oh, yeah. Yeah, you got the idea. Just like when you're going to take an exam, you bring two pens with you. So yeah, redundancy is a must. And when it comes to layer 2 networking switching, the most famous redundancy protocol is spanning tree protocol. That was invented by Radio Perlman, the mother of the internet, which she actually doesn't like to be called the mother of the internet because she very humbly and realistically says that the internet was not invented by any individuals. So spanning tree was introduced in 1985, and as you know, the problem with the spanning tree was that you are going to have a redundant link, but it's going to be in blocking all alternative mode until a failure happens, so you can use your redundant link. So in this picture, imagine that I am switch 1 and I am the root bridge, and other switches have to have a root port to me, and other links are going to be deleted, blocked or staying in the alternative state. So it's a very simple picture that explains a spanning tree, and I have no idea where I stole that from. I just found it on Google Images. So for solving that problem, my Wonder Woman, again, Radio Perlman, introduced TRIL, which stands for Transparent Interconnection of Lots of Links, in 2011, kind of like 26 years after spanning tree. She's a genius. Simply just a genius. So what TRIL does, the TRIL protocol provides transparent layer 2 forwarding using encapsulation with a hop count and ISIS link state routing. That is an IETF specification that enables multipathing in the data center. Yeah. And FabricPath is just simply the Cisco proprietary version of TRIL. Yeah. So how FabricPath works. Here's how it works. When a frame enters the FabricPath network from a classical Ethernet network, the ingressing interfaces, like the interfaces who receive the frame, encapsulate the frame with a FabricPath header, which we are going to talk about that in a few minutes. The software builds paths called trees through the FabricPath network and assigns a forwarding tag or an F tag by flow to all the traffic in the FabricPath network. When the frame leaves the FabricPath network to go to a classical internet network, the egressing interface, which means the interface that the frame is exiting from, decapsulates the frame and leaves the regular CE header, classical Ethernet header. So here is a classical Ethernet frame versus a FabricPath frame. So you are totally familiar with the classical Ethernet frame. We have MAC, layer 2, layer 3, and layer 4. But in FabricPath frame, we are going to see something called a FabricPath header or OMAC or outer MAC. In OMAC, we have ODA or outer destination address, which includes switch ID, which is a unique number identifying each FabricPath switch, a sub-switch ID, which identifies devices or hosts connected to VPC Plus, Virtual Port Channel Plus, if you're familiar with that. And then we have an OSA, outer source address, which just has a switch ID and then F tag or a forwarding tag. So this is the frame that a FabricPath creates. And FabricPath network uses the layer 2 ISIS protocol to forward traffic in the network using the FabricPath headers. So FabricPath headers, what are FabricPath headers? When a frame enters the FabricPath network, the system encapsulates the layer 2 frame with a new FabricPath header, and the switch IDs that the system assigns to each FabricPath device as it enters the FabricPath network is used as the outer MAC destination address or ODA and outer MAC source address or OSA in the FabricPath header. And the frames carry the same tag that is assigned as ingress throughout the FabricPath network, and layer 2 intermediate system to intermediate system allows all switches to have the same view of all the trees built by the software. So as you know, in a spanning tree, we were using float and learn for broadcasting our MAC addresses, but in ISIS we are using something called MDT, which we are going to talk about that too in a few minutes. So speaking about FabricPath configuration guidelines and limitations, FabricPath switches and interfaces carry only FabricPath encapsulated traffic. So you are going to see that all VLANs in a private VLAN must be in the FabricPath mode. And also FabricPath ports cannot be put into a private VLAN. We are going to explain all this soon. FabricPath does not support hierarchical static MAC address, and the spanning tree does not run inside a FabricPath network. So if you're familiar with virtual port channel, you know that spanning tree is running behind the scene, but in FabricPath, it's not using a spanning tree anymore. FabricPath requires an enhanced layer 2 license. We are going to talk about that in the comment lines in a few minutes. And next, speaking about this, let me just give you more information about this now. It means that you actually have to install and enable FabricPath on each switch before you can view or access the comments. Yeah. Very easy. And then FabricPath is a type of class topology. Class topology is simply just a leaf spine topology, that you use in your data centers. One of the very important terms about FabricPath is conversational MAC address learning. So conversational MAC address learning, as I said, in spanning tree we were using flooding and learning, but In a FabricPath, we are using ISIS, which means that we are directly sending our frame to the destination. So each switch learns only those MAC addresses for interested hosts, rather than all MAC addresses in the domain in the domain. In other words, each switch learns only those MAC addresses that are actively speaking with. So let me try to explain it with a drawing here. So here I'm going to show you my spine switches. What is it? Okay, connection. Something that you have to remember, we don't have east-west connection in FabricPath. Okay, so we should not do this. Okay. Oops. I'm doing it with a mouse, you know. That's a horrible graph, but it's all about giving you the idea. So, as I said, this is my source. Let's say this is my source. This is my destination. And okay, I'm sending an arc from my source to this destination. So my leaf switch here receives the frame and it sends it to the spines, and the spines are sending it to the other leaves. So this leaf switch here, this leaf switch, let me just use the other pen. That is me. Okay, it's me. So I am saying that when I get a frame in, first I'm going to check to see if I have the destination MAC address or not. And only if I know the destination MAC address, then I'm going to learn the source MAC address. So yeah, that's it. Okay, so let's back here, see what's up. I'm going to add my spine switches here and turning them on. Also, I'm going to add two routers that I'm going to say that they are not really routers, okay? These are going to be my hosts. Change symbol to server, okay? And server 1, server 2, and links. Okay, from not the management port. Can you hear my CPU's fan sound? That's okay. You can do this, baby. I believe in you. Okay, let me back to my PowerPoint here. Where were we? We were, I guess, here. Yeah. So something else, conversational Mac learning consists of a three-way handshake. That is something that you'd like to know probably. The FabricPath features. Here's are some of the important features of a FabricPath. FabricPath eliminates spanning tree protocol, as we talked about that, with built-in loop prevention and mitigation, time to leave, and reverse path forwarding (RPF). Single protocol plane, single control plane for unknown unicast, broadcast, and multicast traffic. VLAN anywhere. FabricPath is a transparent layer 3 protocols. It is easy to configure, easy to manage, flexible. You can create arbitrary any topology, multiple designs to integrate layer to layer 3 boundaries and start small and expand as needed. It's one of the beauties of class topologies, actually. It's very efficient and scalable. So you have the fast convergence and low latency. I kind of talked about other features before this slide, and also you can have enhanced mobility and virtualization of the FabricPath network. It is capable of running virtual port channel, which actually when you combine FabricPath with virtual port channel, you are having virtual port channel plus. And of course, you have multi-tenant support, traffic engineering, meet security separation requirements via FabricPath topologies. As I said, the algorithm running behind the scene is not a spanning tree, but it is shortest path. And also it uses intermediate system to intermediate system link state protocol. The administrative distance for ISIS is 115, and the cost for ISIS is like for 1 gigabit Ethernet link, you have to use, your cost is 400. For 10 gigabit Ethernet, your cost is 40. For 20 gigabit Ethernet, your cost is 20. So all FabricPath VLANs use conversational MAC address learning, and classical Ethernet VLANs support only traditional MAC address learning, where each switch learns the MAC address of all hosts in the network. So basically, it means that classical Ethernet has no idea what FabricPath is. All right. Here are some general information. Just telling you that did you know that in different cultures, different fingers have different meanings? So for example, in Persian culture, thumb up has another definition. It means like another finger. So if you want to give me one of those fingers, you're more than welcome. It's a wonderful time for that. Merci beaucoup. And if you have any questions, you can find me at vmainush on Twitter. Let's get back to GNS3. Okay, so I'm going to use Secure CRT for these switches. I need some coffee, please. Okay, let's see how's everything. Okay, what's wrong with you, babe? Okay, I have to reload Nexus stage 1. Reload, actually, N7K2, not 1. Let me change the host names here real quick. N7K1. What is it, Mainush? A3. Yeah. All right. Oh, we have to wait for this one a bit more, but I can actually start working on that. So as I said, we have to install the feature set. So very simply, I'm going to say install. Just give me a second. Okay. There are hundreds of books around me and millions of pens. Install feature set FabricPath. Okay. As you can see, it says that a feature grace period is disabled. So first I have to say license grace period, and again I can say install feature set FabricPath. And now if I say so show feature, it says that FabricPath is installed. Okay, there you are. Okay, so that was the installation, but we also needed to enable it. So very simply, we can just say feature set FabricPath. And if I do the same show command again, it says FabricPath is enabled. I'm going to do the same thing on other switches. So first install feature set FabricPath license. I didn't need to do that first. I wanted to do that to show you that what happens if you enter that command without enabling the license. Anyways, license grace period. Grace period. And now install feature set FabricPath. FabricPath. Okay. And now feature set FabricPath. Okay. How are you? Show feature set. Enabled. Okay, good. We also need to enable interface VLAN feature. Okay. So as I said, all the VLANs, they have to be in a FabricPath mode. So first I'm going to create a VLAN, let's say VLAN 10. Okay. And now I'm going to say mode. Okay, so before I change the mode, I'm going to show you what I mean exactly by changing modes. So here you can see that if I say show VLAN, it tells me that VLAN 10 is in classical Ethernet mode. So if I say mode, okay, it's not working with the question mark here. If I say mode, I can see two modes for my VLAN, which are classical Ethernet and FabricPath. I'm going to change it to FabricPath, mode, FabricPath. So I have to go to the interfaces connected to the leaves, to these interfaces, which are interface 2/1 and 2. And I'm going to configure them and putting them in the FabricPath mode. So interface exit interface Ethernet 2/1 and 2 in this range. First and foremost, no shot. And then we're going to put them in the switch port mode because they are layer 2. Yeah, basically keep in mind that FabricPath is a layer 2 feature. And switch port mode FabricPath. And now if I say show FabricPath route, yes, here is my ISIS. It's telling me that these interfaces with this administrative distance are connected to these interfaces. So here, my interface 2/1 with the administrative distance 115 because it is administrative distance for ISIS with the metric 400 is one hop away from my destination. So I'm going to talk about this a bit more with more accurate information. But right now, as I said, the cost for 1 gigabit Ethernet link is 400. So if you can see here, we have metric 800 because in a closed topology, we have 2 hops away from the destination. So we have 1 gig Ethernet here, 1 gig Ethernet here, 400 plus 400 is 800. Yeah, I'm a genius. Yeah. So next, we are going to install and define interface VLANs on our leaf switches, which are connected directly to our hosts. So on Nexus 7K3 and 4 only, I'm going to say interface VLAN 10, IP address 10.1.1.73/24, no shot. And the same here with a different IP address, which is going to be 10.1.1.74/24. Okay. And now I'm going to configure these interfaces connected to my servers, which are interface Ethernet 2/10. Let me see, right? No shot first, and then switch mode, switch port access, VLAN 10 assigned to the VLAN. Did I say no shot? Yes, I said. So if I say show IP interface brief, it says that VLAN 10 with this IP address is up. Okay. The same thing here. Interface Ethernet 2/10, no shot. Switch port, access VLAN 10. Show IP interface brief. Alles gut? What? It's down. Why is that down? Okay, so the reason that it is down is that I didn't say no shot here for interface VLAN 10. So I've got to go to interface VLAN 10, no shot, and again, show IP interface brief. It's up. Okay, good. So now I can go to my quote unquote servers. This is server 1. This is server 2. Hello? Okay. So first, no IP domain lookup because I don't have too much time for this. The same thing here. Hopefully you know what that is. Now I'm going to go to do select the interface host ethernet 0/0 and say no shot IP address is 10.1.1.1 255.255.255.0, and I'm going to do the same thing here, just assigning an IP address to this interface, IP address 10.1.1.2 because they have to be in the same range 255.255.255.0. And now I'm going to say that this router is not actually a router. I'm going to say no IP routing. Oops, no IP routing. The same here, no IP routing. And also, I'm going to assign the gateway, which is IP default gateway, which is going to be 10.1.1.73 for this one and 74 for the other one. IP default gateway 10.1.1.74. At this very moment, we shouldn't have any problems. So let's see. Okay. Let's just ping the other good 10.1.1.2. Okay. All right. So the first one was for ARP, and now it's working. And from here, normally it's working, but why am I doing this? Just for showing this off, huh? So now we want to talk about some verification comments about FabricPath. Okay, so where is my secure CRT? Not here. Okay, so if I just want to choose one of these guys, if you just say show FabricPath, I want to just show you available comments, okay? Some of them that you're going to be using are just FabricPath ISIS followed by some other features, show FabricPath route and show FabricPath switch ID that we haven't actually talked about that still yet, show FabricPath topology, and let me just try a few of them. Show FabricPath topology. Okay, so it says that the topology is up. We have something called multi-topology in FabricPath. For that you can just use show FabricPath ISIS topology. But before I talk about that, I'm going to talk about a very important command for verification, which is show FabricPath ISIS adjacencies. Okay. So here it is telling me that my Nexus 3 and 4 are up and connected via interfaces 2/1 and 2. And that's how I can form my adjacency. I can clear my FabricPath adjacency, ISIS adjacency easily by clear FabricPath ISIS adjacency. Okay, adjacency. Oh, Ethernet and followed by system ID, which I'm not going to do that right now because I don't know what's going to happen, and probably I'm going to receive another error. And just because I'm recording this video on YouTube, I'm not going to edit it. So, anyways, so you know about the clear commands, of course. Like you are clearing your R cache, you're clearing everything. So not everything, but so the other command that I wanted to tell you was show FabricPath, not FabricPath ISIS summary. With this command, you can see what specific F tag number is used in the data plane. Summary, ISIS. Ah, okay, it's not showing it in the virtual mode. Or maybe I am typing a wrong command. Show FabricPath summary. I believe it was show FabricPath ISIS summary, wasn't it? ISIS topology, ISIS protocol, ISIS interface, adjacent system database. Let me just try database. No, it doesn't showing me F tags. So let me just try another one. Show FabricPath route topology 0, because by default everything is in topology 0. So these numbers that you are seeing here, these are your switch IDs. As I said, every switch has an ID that defines which switch is which. Yeah. So we can actually change it very easily because these numbers have no idea for us in case of troubleshooting and verification. So I'm going to say config t fabric path switch ID. This is going to be 71. Okay, because it's changing the switch IDs. That's how it reacts. Exit. Fabric path switch ID. This is going to be 73. Exit. Fabric path switch ID. This is 72. And fabric path switch ID. This is 74. Okay. So if I say show FabricPath route topology 0, you can see that my switch ID is changed, and now it actually makes sense to me that where my traffic is going to. So other verification commands that I would recommend you that you can actually find them here. There is a document by Cisco that these are some verifying the FabricPath advanced configuration, that you can change your load balancing and other features about your FabricPath. You can add security, authentication, and a lot of other cool features. And for finding that, you can just go to cisco.com, and from here you can go to support and downloads. Hello. All supported products, switches, and there are actually two documents, one under 7K switches and another one under 5K switches, 5600 Nexus 5K switches. So you should go to the configuration guides, and the first one here says Nexus FabricPath configuration guide. So, and also in 5500 here, okay, so the same path, you should go to configuration guides, and from here this is the FabricPath configuration guide that if you download it, if you download it. I have already downloaded it. You can also see everything related to FabricPath from here. And also there is another document called FabricPath Best Practice. But if you just Google it, you can actually find it on here. Let me just do it for you because I love you. Oops, where did you go? FabricPath Best Practice. The PDF file, the first one, is actually this file that you can download it and find everything related to FabricPath. So I hope you enjoyed this video. I hope it was informative for you, and thank you for watching, and have a good posture.